Hey, thanks for joining me for this review for the final exam for Algebra 2A. Now, this slide is to remind us that we are going to skip the first question. I probably shouldn't tell you this in a recording, but there's actually at least one question that has a bad answer key, and then there is that at least one question that is from the Unit 2 that we skipped. And that's the first question. So you will see after you've taken this that some extra credit has been added and that the point total has been changed, so that if you were to take the final exam right away, your final score on that would not be the same as what the final score will be. So just keep that in mind as you're taking this test. That first question is something we did not learn in this class, and that's okay. You can move on to the next one. So one of the things that we learned in this class was graphing inequalities. And I want to kind of look at these from two different directions, but we did systems of equations, and that's going to be something for you to check your notes on. But inequalities, I think that covers just about everything. And we're going to take it from two angles here. This first example is taking the equation and drawing the graph, or at least identifying the graph, and then we'll look at looking at the graph and coming up with the equation from that. Alright, so in this first one, remember that we have this this is the y-intercept. That's that key point, and so we'll start with that. The y-intercept is -1. So I'm going to put a nice big healthy point right there at -1. Then we have the slope. And notice that it is negative, so that means it's downhill. Negative slope means downhill. And so we're going to go down 2 spaces for every 3 spaces over that we go, and I'm just going to count that. So I just counted down 1, 2, and then over 1, 2, 3. Now if I want to draw the other kind of the line going in the other direction to the left, then I would just do the opposite. Instead of going down 2 and over 3, I go up 2 and over -3. And that would also be a point on the line. So our line is going to pass through those 3 points. It's going to be going downhill, reading from left to right. Okay, now this equation, or this is an inequality, and this inequality tells us 2 things. It's not equal, means a dashed line. Okay, so if it was equal to, then we would put a solid line. And it's less than, y is less than, so we're going to shade the bottom of the line once we draw the line. So I'll just put a dashed line in here, connecting the points. If I was doing this on a piece of paper, I'd probably use a ruler, and we'll put an arrow at the end of that dashed line, and so you can see that, so we kind of signify that it goes on forever. And then we're going to shade in the underneath. Y is less than, so we're going to shade underneath. And I'll use a highlighter here. Of course, just depends on what tools you have to use, but I'll just shade in with some highlighter lines here. So we're shading in the less than side of that line. And again, that is because when if we imagine we drop a stone, drop a pebble straight down, it hits the top of the line, and so the top of the line is the greater than sides where all the y values are greater than, and the bottom of the line, the underneath that line, is the less than side. It's where all the y values are less than the values above the line. Alright, so now that we have that, let's move on to the same question, only this time we're going to write the equation. And the equation goes like this: y equals m times x plus b. And remember that b is the slope. I'm sorry, I said slope. Wow, I must be tired. That's the y-intercept. Okay. Let's pretend that you're not paying anything for this. Y-intercept. Okay, then the m is the slope. And this time we can see that our slope is positive. Our slope is positive, so it's going to be positive. It's going uphill from left to right instead of downhill. And then we are going to decide here, is it greater than or less than, and is it equal to or not equal to. So we have to decide that, and that's going to dictate what symbol we put in here. Okay, so let's fill in each of these kind of in turn. Put our y there, and then we'll put our x there, and then we'll figure out where's the y-intercept. That's the first thing we'll do, and that's going to be on the y-axis. So we're just looking at our y-axis here. Where does our line hit the y-axis? And that is at positive 1. So 1, 2, 3, 4, and this is 0, 0, the origin. Okay, so that's 1, y equals 1, so plus 1. Alright, so now we have that. Then let's think about our slope. What's the slope? And to get the slope, we need 2 points. And the easiest thing to do is to pick a point that's also kind of where the line hits the crossing lines in our graph paper. So from those 2 points, how many spaces up do we go? And how many spaces over do we go? So we go up 2 over 1. 2 over 1, that's our slope. 2 over 1, which is 2. So 2 divided by 1 is 2. Okay, now we look at our line. Our line is dashed. It's not equal to, so we're not going to use the greater than or equal to or less than or equal to sign. We're going to use just a simple less than or greater than sign. And we drop a stone from up in the air somewhere. We drop it straight down, and it hits the top of the line. And we can see that the shading is above the line. So the shading is above the line, so it's greater than, not less than. So we're going to use a greater than symbol. And there we have it. Y is greater than 2x plus 1 is the equation for this graph. Alright, now let's kind of skip into another unit. We talked about simplifying square roots. Actually, simplifying roots of any kind. This one happens to be a square root. And you remember this was kind of complicated, where we have to figure out the square root of 72, and how do you simplify that, and square root of x to the 6th power, and square root of y third power. Well, and the best way to do this is break this up. I will tell you that you can't do any of this in the calculator. So if your first instinct is to get out the calculator and type it in the calculator, that's going to lead you astray. We're not going to accept an answer in decimal form. If you give the answer in decimal form, you're going to be wrong. So so we're going to break this up into 3 different problems. The square root of 72, the square root of x to the 6th power, and the square root of y to the 3rd power. Those are the 3 problems that we're going to do. And then each one of those in turn we're going to break up further. So 72, we're going to break that up into factor pairs. We're going to say, okay, what times what equals 72? And we have 1 times 72, 2 times, let's say half of 72, that's 35, 36. And we can actually stop there. We can go on 3 times, let's see, 24, 4 times. We can keep on going. That will be our first square, perfect square, 18. So the first perfect square is 4. But if we're doing this methodically and carefully, we will see that our last and biggest perfect square is going to show up typically on this right-hand side. And that's the 36. So remember that we have a whole list of perfect squares: 1, 4, 9, 16, 25, 36. There is our perfect square. 49, 64, and so on. So you should have that in your notes. I'm not going to go into more detail about that. That's our list of perfect squares. And when we're simplifying a square root, the number part, we want to find a number that's in that number, what's something times something else, that is a perfect square, the biggest one possible. So 72 is 2 times 36. So the square root of 36 times the square root of 2. Okay, so once we've done that, then it's easy as cake. The square root of 36, 36 is a perfect square, it's 6 times 6. So that is 6, square root 2. So there's the number part of it. Square root of 72 is 6 square root 2. Now we'll do the variable parts, and we have to remember that if you have the square root of something, a number raised to a power, that's the same as that power, the number raised to the power divided by the root. In this case is 2. If we had a different root, it would be divided by whatever that root is. So in this case, it's x to the 6 over 2 power, which is x to the 3rd power. So that makes that one really easy. The y to the 3rd power, that's not going to be as easy. We need to break that one up. This only works if we have an even root, 2, so we need even powers. So I'm going to say y to the squared times y to the 1st power. So we're going to take out as many the y's until we have 1 y, so that we have an even number of y's left, y squared. And so that's y to the 2 divided by 2 power, which is y to the 1st power, times the square root of y. That's the leftover y that can't be simplified. It's left in the square root. Okay, so now we have 6 square root 2 times x cubed times y times the square root of y. So we'll take all the whole number parts, the parts that were taken out of the square root, 6 x cubed y, and then the parts that were left behind, the factors that didn't have another factor to go with them, that 2 and the y, and there is our answer in simplified form. So that was complicated, that's difficult, but you've got to trust that process. It works every time, and there really isn't a better way to do this. There's no way to get that on a calculator. Alright, now we did some problems where we had square roots and we're trying to find the answer by to an equation with a square root in it. And so our goal in this, just looking at this problem, 2 times the square root of x plus 6 equals x plus 3, our goal is to get that square root by itself, because we want to be able to get rid of the square root by squaring both sides. So I'm going to divide both sides by 2, and I'll get the square root of x plus 6 equals x plus 3 over 2. Now, I did all that so that I can square both sides to get rid of or to undo the square root. Square both sides. So the square root of x plus 6 squared, the square and the square root cancel each other out, and we're left with x plus 6. On the other side, a little bit more complicated. X plus 3 times x plus 3, it's not x squared plus 9. That's what's really tempting to do. It's better to think of this, maybe I'll just write this out, as x plus 3 times x plus 3, and then the denominator it's 2 and 2, 2 times 2. So that's going to be x squared plus 3x is 6x plus 3 times 3 is 9. So we do have our x squared and our 9, but we also have 3x's, 3x plus 3x, which is 6x. And then on the denominator, 2 times 2 is 4. Okay, so if you can imagine, that is x plus 6 equals x squared plus 6x plus 9 over 4. I'm going to multiply both sides by 4 to get rid of that divide by 4 part. So if I multiply the x plus 6 times 4, I get 4x plus 24 equals, and then if I multiply the fraction on the right hand side by 4, it just cancels out the denominator 4, and I'm left with x squared plus 6x plus 9. Okay, now I want to get everything moved over. Now notice what happened. We started out our equation with x's to the first power, but one of them was the square root. And so when I squared, that meant that the x plus 3 got squared. And so now this is a quadratic, and we're going to get two answers. So I'm going to subtract 4x from both sides. And I'll also subtract 24 from both sides. So I get everything equal to 0. So I'm going to write the answers over here. X squared plus 6x minus 4x is 2x. Plus 9 minus 24 is negative 15. Equals 0. Okay, and this is one way to solve a quadratic. We did cover the quadratic formula. You could use that if you want to at this point. I'm going to go ahead and notice that this can be factored pretty easily. X. It's the factors of negative 15 that add up to 2. And let's see, negative 15 is 1 times, or negative 1 times 15, negative 3 times 5, and that, there it is, those are the ones that add up to 2. Negative 3 plus 5 is positive 2. Okay, so since the two things multiplied together equals 0, one of them must equal 0 for that sentence to be true. Either x minus 3 equals 0 or x plus 5 equals 0. In the first case, if x minus 3 equals 0, then x equals 3. If x plus 5 equals 0, then x equals negative 5. Okay, so now those are our possible answers. Now, because this is square root, and we squared, and there initially looked like there should have just been one answer, with there's an x to the first power is usually only one answer, but now we ended up with two answers. There's a very strong possibility that one of these answers is incorrect. We cannot just stop here and say I did my math correctly and I've got the right answer. We must check these answers. So I'm going to go over here on the left side, and I'm going to take my original equation, 2 square root x plus 6, and I'll start with the first answer. X is 3, so 3 plus 6 equals x plus 3, 3 plus 3. So 3 plus 6 is 9, so 2 times the square root of 9 equals 3 plus 3 is 6. The square root of 9 is 3, so 2 times 3 equals 6, and of course that's true. So that answer worked, and we can keep the x equals 3. Now we'll try that again with x equals negative 5. 2 times the square root of negative 5 plus 6 equals negative 5 plus 3. Okay, so negative 5 plus 6 is 1, so 2 square root 1 equals negative 5 plus 3 is negative 2. And square root of 1 is 1, so 2 times 1 equals negative 2. And of course that's false. You can see where that came from. If the square root of 1 was negative 1, then this would have worked out. So this, we have to be careful, because that's the kind of thing that can happen, is that the second answer can relate to the situation where we go with the negative version of the square root. and of course we don't do that, so that's why that one is an invalid or a discarded answer. So we throw out the x equals -5 and we just keep the x equals 3 and move on. Alright, I think we talked about factoring, and actually I'm going to talk about factoring and kind of combine two questions here. Factoring and the roots. And the roots relate to the factors, so if you find the factors, then you can very easily state what the roots are. So let's factor first. Let's see, remembering our factoring steps, the first thing we do is the GCF. Greatest common factor, what do they have in common? 81, that's 9 times 3, a bunch of 3's. X to the 4th, 16, that's 4 times 4, 2, a bunch of 2's. Okay, they don't have anything in common, so the GCF isn't going to help us here. So then we look for our patterns. And remember that the pattern that is most common, or let's say it this way, that's most helpful, the one you should have memorized, is this one. A squared minus B squared. That's the one that's got to be, you got to have that one memorized, got to be thinking about that one all the time whenever you're factoring. And it goes like that. A squared minus B squared is A plus B times A minus B. And lo and behold, that's kind of what we have here. 81 is 9 squared. X to the 4th is x squared squared. And 16 is 4 squared. So we could write this as 9x squared squared minus 4 squared, and so there's our A and B. 9x squared is our A and 4 is our B, and we can write this in the pattern here. It's 9x squared plus 4 times 9x squared minus 4. Alright, that was nifty. And you can see that this is kind of complicated because we've got the x to the 4th power, which means that our factors have x squareds in them. And so we have 9x squared minus 4, and that's a difference of squares also. That is 3x squared. 9 is 3 times 3. X squared is x times x minus 2 squared. So there's another difference of squares. So we could factor that one. That is 3x plus 2 times 3x minus 2. Alright, that's nice. But then we have 9x squared plus 4. Now, normally we would say, well, nothing we can do about that, which is true if we're confining ourselves to the real numbers. If we're only looking for real number factors, then we're stuck. But we did learn, and this is kind of kooky, we learned that there is a way, a form of this pattern, a squared plus b squared, that can be factored if we go to complex or irrational answers. And it goes like this: a plus bi times a minus bi. That's because I times I is -1, and that -1 times the minus b squared ends up giving us the plus b squared. So that's what we're going to use. We already know this is 3x squared plus 2 squared, and so we'll plug that into our formula and we'll get 3x plus 2i and 3x minus 2i. So there we have four factors, and that is the answer of factor this over the set of complex numbers, meaning even if there are complex roots or complex factors, imaginary factors, we'll use those also. Okay, now what's the relationship between what we just found in the roots? We're going to take each factor and we're going to solve for x. that is the roots. So the first one, 3x plus 2i equals 0. We're solving for x, so we subtract 2i, 3x equals negative 2i, and divide by 3, x equals negative 2/3 I. Okay, second factor, 3x minus 2i. We'll go through the same steps, add 2i, only this time we're adding 2i instead of subtracting 2i, divide by 3, and x equals positive 2/3 I. And then we'll do the 3x plus 2 equals 0, the third factor. Subtract 2, divide by 3, x equals negative 2/3. And then 3x minus 2 equals 0. Add 2, divide by 3, x equals 2/3. So we have x equals 2/3, x equals negative 2/3, x equals 2/3 I, x equals negative 2/3 I. There are 4 roots, and we got our roots by taking each factor, making it equal to 0, and then solving for x. Okay, that was a twofer. Let's move on to this one. Find the value of f of negative 3. Now, frankly, you can get the answer here just by plugging in x equals negative 3 into this function. So you could do negative 3 to the 4th power minus 3 times negative 3 cubed plus 2 times negative 3 squared minus 7, and you get the answer. But we learned in this course that we can use synthetic division, so I'm going to take and divide by negative 3, and I'll use my coefficients from x to the 4th, the coefficient is 1, x to the 3rd, negative 3, x squared would be 2, x to the 0 power, x to the 1st power would be 0, x to the 0 power is negative 7. So there's that. We've got to remember to get all the different coefficients of x, including the x's that are maybe missing. Bring down the 1, times negative 3 is negative 3, plus negative 3 is negative 6, times negative 3 is 18, plus 2 is 20, times negative 3 is negative 60, plus 0 is negative 60. It's getting back kind of big. Negative 3 times negative 60 is going to be positive 180. Minus 7 is 173. And that is the remainder. And according to the remainder theorem, that is also the value of f of negative 3. So that's our answer, 173. And we can confirm it by plugging in that negative 3 into each of the values of x here, and just kind of running the numbers on our calculator, we get the same answer. Alright, what are the zeros of this polynomial function? Now that's again talking about the roots, which are talking about the factors, and we know that for this we can use synthetic division as well, and we'll use the other method of synthetic division here. We'll use the coefficients, so 1 for the x to the 4th, 0 for the x to the 3rd power, because there is no x to the 3rd power, negative 7 for the x squared, negative 6 for the x to the 1st power, and then 0 for the x to the 0 power. There is no x to the 0 power, there's no constant term, and so we have to have that, and so we'll have a 0 for that. Okay, now, the numbers that we're going to use here, we're going to start with, well, actually, since 0 is the last, the constant, there's 0, we're going to actually use 0. We're going to get 0 is going to be the answer. So bring down the 1, times 0 is 0, plus 0 is 0, times 0 is 0, minus 7 is negative 7, times 0 is 0, minus 6 is negative 6, times 0 is 0, plus 0 is 0. So this was kind of a dumb thing I did. I could have just divided everything by x, and clearly you can see that x is a factor here, and so x is a factor, or x plus 0 is a factor. Root is 0, so one of the roots is 0. That was kind of silly, but that's okay. It gives me now my coefficients, 4 coefficients instead of 5, and the last one is -6. And so now I can start thinking about the factors of -6 and using those. I'm going to start with 1 with these numbers here. So we're finished with synthetic division there. So bring down the 1 times 1 is 1, plus 0 is 1, times 1 is 1, minus 7 is -6, times 1 is -6, plus -6 is -12. Okay, that's not 0, so that didn't work. Cross that one off, and we'll try -1. That was close, so maybe this will work. 1, bring down the 1, times -1 is -1, minus 0 is -1, times -1 is 1, minus 7 is -6, times -1 is 6, minus 6 is 0, and that one worked. So the remainder is 0, and -1 is a root, or is a 0. It's a synonym of this polynomial function. Okay, so now we're down to 2 left. We've got 3 coefficients left, and we could keep on doing this. We keep doing the guess and check. Notice that the last number there is -6. So we can keep on plugging in our factors of -6 and trying to find which ones come out with a remainder of 0. But because there's only 3 left, there's only 3 coefficients left, that means there's 2 factors left. This is x squared minus 1x minus 6. We can use the quadratic formula and get the answer right away. Say a equals 1, b equals -1, and c equals -6. If we do the quadratic formula, we'll get the answer immediately, even though the quadratic formula is a little bit complicated to throw together here. So x equals -b, so -1, plus or minus the square root of b squared, -1 squared is 1, minus 4 times a times c, which is -6, so that ends up being -4, -6 is positive something, positive 24, over 2 times a, which is 1. So that's going to give me 1 plus or minus the square root of 1 plus 24 over 2, which is 1 plus or minus the square root of 25 over 2. Go ahead and take this up here. That's 1 plus, and let's go ahead and break this apart, 1 plus 5 divided by 2, or 1 minus 5 divided by 2. The square root of 25 is 5. And that's 6 over 2, which is 3, and -4 over 2, which is -2. So there's my last 2 roots, -2 and 3, and those we could have found by guessing and checking by going ahead and continuing with our synthetic division. We would have got those answers eventually, but it probably would have taken me at least 3 more tries to get those. So the quadratic formula gave me the answers right away. So there are my 4 zeros. The zeros are -2, -1, 0, and 3. And that's the end of that problem. Okay, then we talked about rational functions and rational expressions and equations using rational expressions. So that's what we have here. This one's kind of tricky. We have a denominator of x minus 2 and a denominator of x. And so what we're going to do is we're going to multiply each term up here by all those denominators. So we're going to multiply this first fraction by x and by x minus 2. Multiply that second fraction by x minus 2 and by x. And then that third term, which isn't a fraction, we're also going to multiply by x and by x minus 2. So all 3 things get multiplied by the same thing, And there's a purpose. The purpose is to cancel out the denominators. So that x minus 2 in that first fraction gets canceled out when I multiply that fraction by x minus 2. Those two x minus 2's cancel out, and we're left with x times x plus 7. And the x in the denominator of the second fraction gets canceled out when I multiply it by x, and then we're left with just 5 times x minus 2 in the numerator. And then that third one, which is not a fraction, that one I'm going to have to do the whole thing, 3 times x plus minus 2. So we've canceled out kind of the denominators, and now we're going to just write what's left over. X times x plus 7 is x squared plus 7x. Bring down the equal sign. 5 times x minus 2 is 5x minus 10 plus 3 times x minus 2, that's 3x times x minus 2, which is 3x squared minus 6x. Okay, now I am going to combine like terms. I probably should do that first, but I'm going to go ahead and be a little bit lazy. I'm going to subtract an x squared from both sides, subtract a 7x from both sides, so minus x squared minus 7x, so that I can get all my terms on one side. And again, I'm going to go ahead and write those on the left side, even though technically I'm working on the right side. So I have all my x squareds added together, negative. It's 3x squared minus 1x squared is 2x squared. And then I have all my x's, so 5x minus 6x, negative 1x, minus 7x, negative 8x. And then the constant terms, there's only a minus 10 there. Everything got moved over to the right-hand side, but I wrote it on the left-hand side, equal to 0. Once again, we have a quadratic. We could use the quadratic formula here. I'm going to notice that my we can factor this fairly easily. There's a common factor of 2, so take that out. X squared minus 4x minus 5. And then that x squared minus 4x minus 5. Negative 5 is negative 1 times 5, or negative 5 times 1. Negative 5 plus 1 is negative 4, so it's x minus 5 and x plus 1. Now, since all of that together equals 0, each of those factors, one of those factors would have to equal 0 for this to be true. Of course, 2 cannot equal 0, but x minus 5 can equal 0 if x equals 5, and x plus 1 could equal 0 if x equals negative 1. So those are the two different ways that sentence can be true. And so those are the two solutions. Now, I forgot to do something way at the very beginning. When we were starting the problem, we needed to start the problem by asking ourselves, well, what is x not allowed to be? And x is not allowed to be something that would make a fraction have a 0 in the denominator. So we should have said right off the bat, x minus 2 can't equal 0, so x cannot equal 2. And then the denominator of the second fraction, which is x, cannot equal 0, so x cannot equal 0. Those are the two kind of caveats. We can't have x be any of those numbers. And when we solved this, it turned out that x did not equal any of those two numbers. X equals 5 or negative 1. Those are the answers. So we would say these are the numbers that x equals, and that's our solution. We can check our answers by plugging them back into the original equation and make sure that they're true. But that's it. Okay, let's talk about this one. This is kind of giving us bad flashbacks to that first unit when we had all the tech trouble. This is a fairly easy problem, and we have this from our notes, this image from our notes. So that's what I want us to. We're going to reference that in just a minute. The number of chocolate chip cookies in in the cookies in my cookie jar are normally distributed with a mean of 17 and a standard deviation of 2 chocolate chips. So we've got this picture here. Remember, the idea is that the middle number in this is the mean, which is 17. And then we have this thing called the standard deviation. And so standard deviation is 2. So if we go up 1 standard deviation, that would be 19. And up 2 standard deviations plus 2 again would be 21 chocolate chips. And so on. 3 would be 23. Or we go down a standard deviation, which would be minus 2. So it would be 15, and then 13, and then 11. Okay, so those are kind of the distribution of the numbers of chocolate chip cookies within the chocolate chips within these cookies. And the question is, how many cookies are between 15 and 19 chocolate chips? Is right at the top there. How many cookies are between 15 and 19? And lo and behold, we have the number 15 already on my chart, and 19, that's 1 standard deviation below and 1 standard deviation above. And so according to this picture in our notes, that's 34% are between the middle, the mean, and 1 standard deviation below, and 34% are between the middle and 1 standard deviation above, for a total of 68% of all the cookies. So that's 68% of the cookies, which could be the answer, but this said how many actual cookies are, and there's 74 chocolate chip cookies total. So that is 68% of 74, which is a fancy math way of saying 0.68 times 74, which is what our calculator can do. Our calculator can do that. And on the calculator, it comes out to approximately 50. So 50 cookies have between 15 and 19 chocolate chips. And I know you're feeling very sorry for me for being the kind of person who sits around and counts how many chocolate chips are in my cookies. But that's just the way I am. You have to get over it. Okay, this is another one of those. Now, this one actually kind of looks like it might end up being one of those rational expression type of problems, but this is actually an inequality. It's kind of going back to that first question we did where we were graphing an inequality. This is one where we're solving an inequality. There's only one variable x, and when we are dealing with expressions, equations, especially with fractions in them, we want to get rid of the denominators. We want to get this into an easier to deal with form by getting rid of the denominator, by multiplying by the common denominator. So just like we did in that last rational equation, we're going to multiply by the common denominator of whatever denominators we can see going on here. So we have a 12th, a third, a 6th, and a 4th, and I think you can see that all of those numbers can be divided evenly into 12. 12 divided by 12 is 1, divided by 3 is 4, divided by 6 is 2, and divided by 4 is 3. So they all go in evenly. So what we're going to do is we're going to come along and we're going to multiply each part of this by 12. So the parts are going to be delineated by the plus and minus signs. So there's a part right there. I'm going to multiply that by 12. So times 12. And then the second fraction, 1/3, I'm going to multiply that times 12. And then now here, this is a little bit tricky. This is 1/6 times x minus 1. So that is one whole unit right there. So I'm going to multiply that by 12. And then the 1/4 with a minus sign in between, that's another unit. Now I'm going to multiply that by 12. Okay, so now when I multiply things by 12, what happens is all the denominators get canceled out. That first denominator just gets canceled out outright, and so that becomes just x. So that first one, that was easy, x. The 1/3 divided by 12, or times 12. 12 times 1 is 12, divided by 3 is 4. Probably the easiest way to think about that. Okay, we've got our greater than or equal to symbol. Now, 1/6 times x minus 1 times 12. I can do the 1/6 times 12 first. So 12 times 1/6, 12 times 1 is 12, divided by 6 is 2. So that becomes 2 times x minus 1. Now, this works because that's all one big multiplication problem, and I'm allowed to do multiplication if I've got like 3 things we multiply them in any order. So I chose to multiply the 1/6 times 12 first, and then we'll deal with the answer to that, which is 2 times the x minus 1 second. All right, 1/4 times 12, that's 12/4, which is 12 divided by 4 is 3. And now we have the exact same inequality, but much easier to deal with. So right, x plus 4 can't really be simplified all that much. Greater than or equal to 2 times x minus 1 is 2x minus 2, and then that minus 3. All right, so that's pretty easy. We want to get all the x's on one side, and I think what I'll do is I'm going to subtract 2x from both sides. So I'm going to have all the x's on the left. Since I'm doing that, I will go ahead and say minus 4 to get all the non-x's on the right. So 2x minus 2x is 0, 4 minus 4 is 0, and so we're left with just x minus 2x, which is negative 1x, is greater than or equal to negative 2 minus 3, and then the minus 4, which is negative 9. Now, we want to find out what x is, not what negative x is, so we're going to divide by negative 1. Now this is the tricky spot for inequalities. Remember that if I multiply or divide both sides by a negative number, and that's what I'm doing here, we swap the inequality sign. So negative 1 divided by negative 1 is 1, 1x, but I have to swap the inequality sign. Now it's less than or equal to, and negative 9 divided by negative 1 is 9. So x is less than or equal to 9. We can graph that if we want to. 0, 3, 6, 9, 12. Less than or equal to, so close circle, arrow going in the less than sign, and draw the graph there. And there we have it. Okay, so that is solving an inequality by isolating the variable. Okay, we're going to kind of do some simple problems where we're just simplifying. Here's one where we're just multiplying a binomial times a trinomial. Not that difficult, but it's important to remember all the steps. We are multiplying two binomials together. We did the FOIL method. Here we have a binomial times a trinomial, so we'll still do the kind of the FOIL method, but it's going to just be one extra step for each. So instead of first, outer, inner, last, we're going to do that first term times each of our terms. X squared times x cubed is x to the 5th power, plus x squared times 2x squared is 2x to the 4th power. X squared times negative 1 is negative x squared. And then we'll take the second term, negative 3, multiply it times each of the terms in the trinomial. And instead of writing the answers on the same line, I'm going to just go down one. Negative 3 times x cubed would be, ooh, look at this. I'll go ahead and just write this here. Minus 3x cubed minus 6x squared, and then minus, plus 1. Negative 3 times negative 1 is plus 3. I said that wrong. Then we'll combine like terms, and here the only like terms I have are the negative x and the negative x squared, negative 6x squared. So it's x to the 5th plus 2x to the 4th minus 3x cubed minus 7x squared, negative 1 plus negative 6 is negative 7 plus 3, and that's my final answer Got kind of a crooked looking X there at the beginning. Sorry about that. Okay. That's fairly simple. Now let's do this problem. We're graphing, and we have to kind of remember what we said about if the exponent is 3, if it's odd, that means that our graph is going to kind of go from small to big. It's going to go like this. But if it's 3, it's going to have some loops to it, so it's going to look sort of like this. If it was a negative number in front, it would have gone down like this. But that's kind of what we're looking for. We're looking for that upward going graph, and so we'll look for that. The best way to do this is to do our synthetic division. So we're going to do synthetic division to plot points, and then we'll plot a bunch of points, and then we'll sketch the line that connects the points, and hopefully we'll get a good sense of what this looks like. So we'll do synthetic division with 1 for x cubed, -2 for x squared, -1 for x to the first power, and 2 for x to the 0 power. And I'm just going to start with, I don't know, maybe I'll start with -2 and just go from there, -1, 0, 1, 2, 3, just see what happens. And remember that our remainder is going to be the y value. So our x value is going to be what we're plugging in, and then our y value is going to be just what the remainder is in each case. So bring down the 1 times -2 is -2 minus 2 is -4 times -2 is 8 minus 1 is 7 times -2 is -14 plus 2 is -12. Okay, so our first point is -2, -12, which is way off the graph, so we won't be able to plot that one, but it's what we expected. We expected that the left side of the graph to be really low. It's going to start out really small. Okay, let's go to -1. So bring down the 1 times -1 is -1 minus 2 is -3 times -1 is 3 minus 1 is 2 times -1 is -2 plus 2 is 0. Oh, our next point is -1, 0. So it starts out really low and it goes all the way up to the x-axis at this point right here. Okay, so it starts out really low, all the way up to 0. Okay, let's do the next one. Now this one we don't actually have to do synthetic division on. We know that when x equals 0, y equals that constant term is just going to be 2. So it's going to be 0, 2. So we can plot that one, 0, 2. We could have done synthetic division if we'd forgotten. There we have it. Okay, let's do 1. So bring down the 1. Times 1 is 1, minus 2 is -1. Times 1 is -1, minus 1 is -2. Times 1 is -2, plus 2 is 0. Oh look, we found another root. 1, 0 is our next one. 1, 0 is right there. Okay, so we can see that it looks like it goes up and then it hits the y-axis at +2 and then it turns around and comes back down. Let's see where it goes from there. So 2, bring down the 1, times 2 is 2, minus 2 is 0, times 2 is 0, plus -1 is -1, times 2 is -2, plus 2 is 0. So we found another root, 2, 0. So right there. Now what had to happen then is at some point between 1 and 2, it passed through the x-axis and went down, and then it turns the corner and comes back up again. Okay, so let's see what happens at 3. Bring down the 1, times 3 is 3, minus 2 is 1, times 3 is 3, minus 1 is 2, times 3 is 6, plus 2 is 8. So 3, 8, and you can see that 3, 8, just in my little graph, little coordinate plane here, is off the graph, but we kind of expected that also, that it's gonna head up north now, so we're going to see that characteristic kind of S shape in the middle, but then on the left and the right it's going to go up or down and up respectively. Okay, so let's see if we can kind of sketch this in. We'll go ahead and just kind of draw a line. It's going to hit the first y-intercept, and then it's going to x-intercept, y-intercept, then it goes down, and then it's going to turn the corner fairly quickly to go back up here, and then it's going to go up here somewhere. Okay, so that's sort of what our graph looks like. Now we could plug in x equals, or we could plug in 3/2 here to, if we want to kind of see exactly where that goes and how far down it goes. We could plug in 3/2 and do synthetic division with that, and we really could do that. We would get an answer. It would probably end up being a decimal answer. It'd be kind of difficult to do that accurately in our heads. We'd probably want to use a calculator, but this I think is a pretty good representation of how to draw a graph using synthetic division to plot your points. Alright, we're going to simplify this one. Remember that when we have polynomials, numerator and denominator, that means we want to factor. So when we're thinking of factoring a trinomial, we're hoping we can break it down into factors like that, and we've got the x and the x, and then we're going to need to find the factors of -15 that add up to 2, so we're going to do -15 is -1 and 15. -2 doesn't work, -3 and 5. And looky there, -3 plus 5 is 2. So we use that, so x minus 3 and x plus 5. So to factor this bottom one, that's not going to be as easy. In fact, I don't even know why I just did that. We can't just do those parentheses. It's not as easy to do that. In fact, what we're going to do is we're going to start off with turning this from a trinomial to a 4-term polynomial. So to do that, we're going to take the first number, 3, and the last number, 6, and multiply them together. 6 times 3 is 18. And then we're going to ask the same question. What factors of 18 add up to -11? So we know that has to be negative numbers. Negative times a negative is positive, positive 18. So -1 times -18, -2 times -9, and wouldn't you know it, there it is again. We did it again. -2 plus -9 is -11. So we're going to take this and split that middle term apart. So 3x squared minus 2x minus 9x plus 6. So we split that middle term apart. Then we're going to take and we're going to group the first terms together and the last terms together. I'm going to do it like this. Let's see, I've got to be careful here. I'm going to say plus -9, so that'll be a little bit helpful there. Okay, so what are the common factors in that first pair, 3x squared minus 2x? The only thing they have in common is the x, so I'll take that out, x, and then left inside will be what's left over, which is 3x minus 2. Okay, for my second pair, I'm going to say, what do they have in common? Well, first of all, I don't like having that negative there at the beginning, so I'm going to divide by a negative, and I see that 9x and 6 both have a 3 in common, so I'll just divide by a -3. So I'm going to take out a -3, and I'm left with 3x, and then 6 divided by -3 is -2. And that was, I meant to do my ink colors here the same. There's my 3x minus 2 is the same in both cases. So now I treat this as one big binomial, and both parts of it have something times 3x minus 2. I'll take out the 3x minus 2, and what's left over is the x minus the 3. Okay, so that was a little bit complicated. We complicated factoring that, but when we finished, we're left with x minus 3 on top times x plus 5, and x minus 3 on bottom times 3x minus 2. The x minus 3's cancel, and we're left with x plus 5 on top divided by 3x minus 2 on the bottom, and there we have it. Simplified. And that is the end of the review. Thank you very much for watching. I hope this has been helpful, and good luck on that test.